Hello everyone, this is Priyanshu Choubey, Assistant Professor of Chemistry and Biology. Today we will going to start some soil related terminology. So let's see. An introduction to soil and soil terminology. Um, Soil some definition, soil can be defined as a solid material on the Earth's surface that results from the interaction of organic and biological activity on the parent uh, material under hard rock. The study of soil as a natural occurring phenomena is called pedology, from a Greek word "pedon", meaning soil of earth. Pedology takes into account factor and process of soil formation, soil characteristics, and distribution of soil types. The basic unit of study soil profile or soil profile is a vertical cross section of a soil. It is divided into a number of distinct layers referred to as horizons. The horizons are normally designated by the symbols and letters. The presence or absence of a particular horizon allow the pedologist soil scientists to classify the soil. In addition, the organic or horizons can form above the mineral soil commonly in forested areas, resulting from and dead plant and animal humus. Uh, in the picture, topsoil upper or A horizon, subsoil middle or B horizons, and last parent material uh, lower or C horizon. This diagram shows a simplified soil horizon. Soil horizons, the horizons may be further subdivisions. For example, in this soil profile, A horizon has been divided into four further pedological horizons. L means leaf litter, F means fermenting leaf litter, H means humus, and E means alluvial. These lie above the B or alluvial horizon. In this picture, fresh vegetables, dead vegetable litter L, and fermenting litter F, and humus S, and alluvial horizon E, and alluvial horizon B. Soil forming factors. Soil develops as a result of the interplay of five factors: parent material, climate, organism, relief, and time. Parent material. Soil forming factors: parent material, climate, organism, vegetation, fauna, and soil biota. Relief, land forms and topography, and time. Over a factor for a further explanation, use a black bottom to represent to this slide advance two slides on a soil process by click. Parent material. This is the material from which the soil has developed and can vary from a solid rock to deposits like alluvium and boulder clay. It has been defined as the initial state of the soil system. Jenny, at 1941, he gave a soil forming equation factor of a soil formation. The parent material can influence the soil in number of ways: color, texture, structure, mineral composition, permeability, and drainage. This soil has developed on old red sandstone has derived and its distinctive color from its parent material. Climate: this probably the most important factor. Soil uh, produced from the same parent material under different climatic constructs. Climate governs the rate and type of soil formation and is also the main determinant of vegetation distribution. Soil climate has two major components: moisture, precipitation, and temperature, increasing evaporation. When precipitation exceeds evaporation, leaching of the soil will occur. Temperature determination the rate of reaction, chemical and biological decay, and 50 and so has an influence the weathering and humidification. Organisms, vegetation, fauna, and soil microbes. Organisms increasing soil development range from a microscopic bacteria to large animals, including microorganisms such as the bacteria and fungi, acids, in the decomposition of plant litter. This litter is mixed into the soil by a microorganism soil animals such as the worms and the beetles. Soil horizons are less distinct when there is much soil organism activity. Higher plants influence the soil in the many ways. The nature of the soil humus is determined by the vegetation cover and resultant litter inputs. Roots contribute spread roots to the soil, bind soil particles together and can red redistribute and the compressed soil. Relief, landforms and topography. Relief is not a static, it is a dynamic system. Its study is called geomorphology. Relief influences soil formation in several ways.
Is a particular importance in the absorption of the water and the circulation of air. A desirable structure should have a higher proportion of medium size aggregates and an prescribable number of an appreciable number of the large pores through which water and air can move. Structure of both the B horizon and A horizon is a very crucial to a proper drainage in infiltration and productivity in soil with a poor structure. Root penetration in limited, thus the reducing the plant's access to water and nutrients. The structure of the A horizon has received great deal of attention because of the its relation to seedbed preparation, B, horizon potential, aeration, water infiltration, overall soil health. So let's see soil structure. The primary soil particles do not exist as um, such in a natural condition, but the broad bonded together into a large units of aggregates, usually termed as secondary particles. These aggregates formed under a natural condition are called pads. Whereas an irregular shaped coherent mass of soil formed during a tillage operation is called a clod. Soil structure is defined as the arrangement of a primary and secondary soil particle in a certain structure pattern. This arrangement result in information of different sized soil pores. Therefore, a soil structure may also be defined as the arrangement of the various sized soil pores in certain structure pattern. So now is the important of soil structure. Soil structure influence almost all the plant growth factors like water supply, retention, aeration, availability of a plant nutrient, heat, root penetration, microbial activity, and etc. Strong aggregations decreases uh, decrease detachability and transportability of soil particles by water and wind, and thus reduce the runoff and soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of fertilizer, manure, lime, gypsum, and irrigation. Classifications of soil structure. Uh, Soil structure is described and classified based on the types of the type as determined by a shape and arrangement. The class as a differentiated by a size, and third one is the grade as a determined by a distinctness and the durability of pads. So types of structure based on shape and arrangement of a pad. Soil structure is classified as a simple and the compounds, and simple structure, natural cleavage, planes are absent. Simple structure is of two types: uh, simple granite and massive. In single granite structure, particles are completely unattached to each other, as in case of a loose sand. And while in a massive structure, particles are the bonded in a large cohesion, non-structured mass. In case of a surface crust, plow, pane, and the clay pan. In compound structure, In compound structure, natural cleavage planes are visible with a naked eyes. This shape are individual paired and described according to relative length and vertical and horizontal axis by a shape and their edges. Compound structure is four types of depending upon a shape. and their characteristics like first one, types of compound soil structure and their characteristics. Type 1 is a blocky all shape and characteristics of a blocky, all the three dimensional of a pets are of about same size, providing a shape of a block having a flat and rounded face. These pets are further divided into a angular blocky and the subangular blocky. In the former face are a flat and the edges and corner are sharp, while in the letterfish and the edges are mainly rounded. The blocky structure usually found in a B horizon and promotes good drainage, aeration, and root penetration. Second one is a prismatic. Prismatic, the pads are elongate more in vertical than in a horizontal direction. Given a column-like shape, vertical cleavage planes are the predominant. When the top of pads are relatively angular and flat, is called a prismatic. And when rounded, it is called a columnar. Prismatic structure commonly occurs in subsurface horizon in a arid and semi-arid region, and poorly drained soil of a humid region having a swelling type of clay. Platy horizontal axis is a longer than a vertical axis, resulting the plate-like appearance. Horizontal cleavage planes are predominant. When the pad are s- thick, they are called platy, and when thin are called laminar. Platy structure is often inherited from a parent material and may also be formed due to a compaction of a clay soil by a heavy machinery. Plate structure restricted infiltration and percolation and aeration soil. Spherical pits are roughly spherical and granular and subdivided into a granular and crumbs. Granular structure is less porous than the thumb due to a low organic matter content. Spherical structure formed by a biotic activity in surface horizon and promotes infiltration, percolation, aeration, and root penetration in soil. Classes of soil structure on the basis of size aggregates. Each type of soil structure is further subdivided into five classes. The size of aggregates is a certainer of quantitative classifications of soil structure. Chorus and sand size aggregates are more favorable for plant growth and very smaller or very large aggregates. So grade of soil structure. Grades of soil structure. It is a qualitative means of the classification of soil structure. Qualitative means of classification of soil structure. Grades of soil structure are the identified on the basis of the stability of the grades. Stability of a grades refers to their resistance to disruption by impact of raindrops under a submerged condition. It is influenced by a moisture content amount and type of clay and nature of the adsorbed cation and organic matter content of a soil. High moisture content, colonite clay, developed cations and high organic matter content make the aggregates relatively soft. Three structure grades have been identified as a weak, moderate, and strong. So, grades of soil structure. To describe to soil structure, the sequence, grade, class, and type of the followed for example: strong, porous, angular, blocky, moderate, thin, platy, and weak, fine, prismatic structure. Like a great weak, first one is weak, so characteristics are poorly formed, indistinct pads with which are not as stable. Moderately developed pads which are fairly stable and distinct. A strong, a very well developed pad which are quite stable and distinct. So genesis of structure refers to the uh, cases and the method of formation of aggregates. The following two processes are the involved in the genesis of structure. First one is a flocculation. Flocculation. Flocculation, it is an electrokinetic phenomena is in which positive and negative charge are involved in a soil water suspension, and the clay particles with a high zeta potential repel each other. With the addition of fluctuating agent, zeta potential is lowered. The particles come closer and attract each other, resulting in the formation of floccles of silt size. Floccles are stable as long as the flocculating agent is present. Flocculations also take place due to hydration, high soluble salt concentration, and the presence of the divalent or trivalent cations. Cementation of floccles. It refers to consolidation of a clay foccolates by a cementing material so that they may not get displaced. Once this have been a flocculate, as a floccolates are not a large than a silt size. Therefore, flocculations would be unfavorable for a plant unless these are further aggregates by inorganic calcium carbonate oxides of iron and aluminium and organic matter cementing materials. Flocculation of a clay particles is therefore the request for aggregation. So aggregation is always refers to a flocculation plus where a plus in the cementing agent. Factors influence the formation and the stability of the soil structure. So first one is the physical factors. Physical factors includes the wetting and drying, and freezing and thawing. Alternate wetting and drying leads to a formation of a smaller aggregates, particularly in the fine texture soil. Drying causes a shrinkage of the soil mass, and when a large dry cloud is wetted, rapid entry of water causes unequal swelling in the cloud, and the cloud is fragmented along the cleavage plane. In the process of wetting, increasing the pressure of the interrupt air cases distribution of the large cloud into a smaller pieces. Similarly, freezing cases cracks in the large plot by expressions of a water. These cracks, cracks takes in more water upon thawing and get enlarged further of the refreezing. Chemical factor. The chemical factors includes the exchangeable cation and the binding materials. Clay acts as a cementing agent, also swells shrinkage upon the wetting and drying. In certain also small aggregates are held together by a covering of the clay particles. Exchangeable ions such as the calcium, magnesium and potassium have a flocculation effect on the clay, while sodium has a dispersing effect. The sodium ions dominating on a exchangeable complex of a sodic soil cause particles or repel each other and hinder the formation of the aggregates. The divalent cations such as the calcium and magnesium causes the individual colloidal particles to come together and form foccolates. Calcium also help in binding the organic colloids and clay particles. Hydrate Swaxe oxide from almost completely inversible colloid upon dehydration, and the uh, and help in forming stable aggregates as in the lateric soil, oxysol, and alti soil called the lateric soil of the humid tropics. So, Swaxy oxides also formed a complex with humus and calcium carbonate precipitating around soil particles act as the cementing materials for aggregates and imparts a stability to soil aggregates. Soluble salt and to enhance flocculation of the clay even in the sodium saturated clays. Organic compounds play a key role in aggregation and stabilization of soil structure. Fat, wax, lignin, protein, raising, etc. also help stabilizing the soil aggregates. Humans help in the aggregation by the forming clay humus complex. Only a calcium humus is a focculating due its tendency of form a complex with the organic compounds through the coordinations linkage, the
Plays a particular
magnesium,
importance
potassium, and
in
hydrogen
the
and sodium
absorption of the water
humus is
and the
defocculated
circulation of
and does
air.
not help in
A
aggregation.
desirable
Synthetic soil
structure should have
conditions.
a higher
Long
proportion of
carbon
medium
chain organic
sized
aggregates
compounds are
and
also
an
used for a soil
uh,
aggregation. These compounds
appreciable
attach
number of
tangles to the inner exchange sites
an
of the clay and the
appreciable
bind
number
the
of
clay
the large
particles
pores
together. Addition
through
of these
which water and
compounds
air can
in
move.
relatively
Structure
small
of
amounts and
both
can
the B
produce a
horizon and
good
the
structure even
A
a sandy
horizon
soil.
is a very crucial to a
Biological
proper
effects,
drainage in
biological factors.
infiltration and productivity in soil with a poor structure, root penetration in limited,
Biological
thus
factors, the plants
uh,
and plant residues
reducing
help
the
the soil
plant's access to
particles to
water
bind
and
together.
nutrients. The structure
Um,
of the A horizon
Gelations,
has
organic
received a
compounds
great deal of
extrude from
attention
a root binds and
because
soil
of the
particles together.
its
Root hairs
relation to
penetrate soil
seed bed preparation,
clots
B
to create a
horizon
point of the weakness and the
potential aeration,
ultimately
water
break the
infiltration.
clot into
Overall,
aggregates.
soil
This
health.
also help
So
the
let's
soil
see soil
particles stick
structure. The
together
primary
in
soil
a
particles do not exist
granular
as
form.
such.
Plant residues serve
Um,
as a food for
such
microbes
in
which
a
play a prime
natural
role in the
condition, but
aggregates
the
formation
broad
and the produce sticky
bonded together into a large units of
substance or
aggregates, usually
decompositions.
termed
Microorganisms
as
decompose
secondary
plant and
particles.
animal residues form humus, and this humus binds the particles
These
together.
aggregates
Algae,
formed
fungi,
under a natural
actinomycetes, and
condition are
bacteria,
called
which continue
pads.
the living matter in a soil bind.
Wears an irregular
Soil
shape,
particles more effectively than the
coherent mass of
exchangeable
soil
ions.
formed
The
during a
small
tillage
animal like
operation is called
rodents,
clod.
earthworm, spiders, mites, nematodes, insect, centipedes, and
Soil
millipedes,
structure
etc.
is
Uh,
defined as
Facilitated
the
the
arrangement of a
formation of
primary and
soil aggregates by
secondary
way
soil
of
particle in
boring,
a
turning the
certain
soil
structure pattern.
or
This
throughoutly
arrangement result in an
mixing
information of
the
different
organic residues
sized
with
soil
the soil.
pores. Therefore, a soil structure may also
Evaluation
be
of a
defined as
soil
the
structure.
arrangement of
The
the
soil
various
structure
sized
can
soil
be
pores
evaluated both of a
in
direct and
certain
indirect
structure
method.
pattern.
A direct method.
So now is the important of a soil
Direct method,
structure. Soil
indirect
structure
method soil
influence
structure is
almost all the
characterized
plant
by the
growth
observing the
factors,
shape, size, and
like water supply,
arrangement of the soil aggregates.
retention, aeration, availability of a
Either
plant nutrient,
microscopically
heat,
or a
root
microscopically
penetration, microbal activity, and etc.
microscopically and
Strong
aggregations
decreases
Cally. In microscopic technique, thin soil section are exempt under a various
decrease
types
the
of microscope
detachability
for
and
shape and size of aggregates
portability
of
and
soil particles by a water and
voids
wind, and thus reduce a runoff and a soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of
for
fertilizer, manure,
microscopic
lime,
evaluation a
gypsum,
large
and
soil clouds
irrigation.
in
Classifications of soil structure. Clouds, it's a uh, soil structure is described and
excavated
classified
from
based
the field
on
and
the
allowed to
types of
fall gently to
the type as
gently on a
determined
smooth
by a
surface
shape
which
and
breaks
arrangement.
into
Pads of a different size and shape. Shape and size can also be
the
observed
class
directly
as
from
differentiated
the
by a
cleavage,
size
and
of the
third one
pads
is the
in the
grade
soil
as
profile.
determined by a
Indirect method involves the
thickness
measurement of the
and the
size
durability of
distribution of pads.
stable aggregates. So
Stability of aggregates of the soil
types of structure based on
property,
shape and arrangement of a paired soil structure is
which is the
classified as
function
a
of
simple
soil
and
structure. Soil
compounds
is
and simple
indirect
structure,
method,
natural
size distribution of
cleavage,
stable
planes
aggregates.
or
So,
absent.
dry or wet sheaving techniques are used for
Simple
determination of
structure is
different
of
size
two
stable
types: single
uh,
aggregates,
simple
indirect
granite and
dry
massive.
shaving techniques. The proportion of a
In
stable single aggregates
granite structure,
against
particles
a
are
vibrating
completely
action
unattached
stimulating
to
of
each
the,
other.
as in case of a loose and
Scoring
effect
while
of a
in a
wind is
messy structure,
determined, which
particles
the
are the
provides
bonded
and the
in a
index
large
for a
cohesion,
characterizing
structured
the
mass in case of a
susceptibility
surface
of soil
crust,
to wind
plow,
erosion in
pane, and the clay
wet
pen.
shaving
Compound
technique. Size
structure
distribution of water stable aggregates in determined Measurement of the stability of aggregates.
In compound
It
structure,
is
natural
evaluated by
cleavage
the degree of
planes
the
are
which soil
visible with a
aggregate
naked eyes.
resist
This
dispersion.
shape are
Several indicates have been
individual paired and
developed, such as the
described
stability
according to
index,
relative length
structure
and vertical
coefficient,
and horizon
and
axis by
dispersion
a shape
coefficient,
and their
stability index, and
edges.
is the
Compound structure is
difference between
four
percentage
types
silt
of depending
and
upon a
clay
shape
as determined by the mechanical analysis, and that the
and
often
their by
characteristics
suspension
like
of
soil
first
sample
one
in water.
types of
The
compound soil
grade,
structure and their
the difference,
characteristics.
the
Type
better
1 is
in
a
the soil
blocky
structure.
all
Structure
shape and characteristics
coefficient is
of a
given by
blocky all the
uh,
three
d
dimensional
minus s
of
upon s,
plates are of about same size
where d is a
providing
percentage of
a shape
particles
of a block
and less
having a
than
flat and rounded
0.25 mm in
face.
diameter
These
as
pits are further
determined by the mechanical analysis, and the s
divided
is the
into a
percentage of the
angular
aggregates is
blocky
smaller
and
than
the sub-angular
0.025
blocky.
mm in
In the
diameter
former
as
phase,
determined by the
are
wet
a flat
sieving
and
method.
the
High
edges
the value of
and
the
corner
structural
are
coefficient,
sharp,
the better is the soil structure.
while in the
Measurement of the soil properties,
latter
bulk
phase and the
density,
edges are mainly
infiltration rate,
rounded. The
hydraulic
blocky structure
conductivity,
usually found in
aeration,
a B horizon
available soil
and
water,
promotes
degree of
good
compaction
drainage,
of soil
aeration,
may
and
be
good
used for evaluation of
penetration.
soil structure. So indicates of a
Second one
soil
is a
structure
prismatic.
amount of a
Prismatic,
different size
the
soil
pads are
aggregates is represented by
analogate
the single
more
value
in
of the
vertical than in a
comparing the
horizontal
structural states
direction.
status of different soil or the same soil
Given a
under
column
different
like
management
shape, vertical
particles. Among
cleavage
various
planes
indicates
are the
mean a
predominant.
weight diameter of the aggregate
When the top of pads are relatively angular and flat, is called
is
a prismatic,
commonly used index of soil structure.
and when rounded,
The
it is called a
mean weight or
columnar.
diameter of aggregates gives an estimate of a weighted
Prismatic
a
structure
percentage of the
commonly
average
occurs in
size of all
subsurface
the
horizon in
aggregates.
a
The
arid and
proportion by
semi-arid
weight
region
of the given size friction of the aggregates to the total sample weight
and
is multiplied by
poorly
the mean
drained soil of
diameter
a
of
humid
the that
region
frictions. The
having
sum
a
of these
swelling
products for the
type
all
of
size
clay.
frictions gives a mean weight diameter of aggregates in a
Platy
mm.
horizontal axis is a
Uh,
longer than a vertical axis, resulting the plate-like appearance. Horizontal cleavage planes are predominant. When the pad are
Management of a soil structure.
thick,
So the
they are
general
called
practices for the
platy,
improvement of the
and when thin
maintenance of
are
the soil structure,
called
tillage
laminar.
operation be carried out within the range
Platy
of the
structure is
optimum moisture
often
condition to ensure least
inherited from a
destruction of
parent
the soil
material
aggregate. Zero and minimum tillage practices
and may
be
also be
adopted to
formed due to
maintain
a
adequate
compaction
aeration and the
of a
reduce the
clay
loss
soil
of
by a
organic
heavy
matter
machinery.
through oxidation
Plate
of
structure
erosion.
restricted
Soil surface be
infiltration
kept
and
covered with the crop
percolation
residues
and
to
aeration soil.
protect aggregates from the beating action of
Spherical
raindrops. Check wheat
pits
emergence
are
and add organic matter.
roughly
Incorporation of the crop
spherical and
residues and the
granular and
manures into the
subdivided
soil
into a
for the
granular
stabilizing
and
aggregates.
crumbs. Granular
Introduction
structure is less
of
porous
legumes in
than the
crop
thumb due
rotation
to a
coupled
low organic
with the application of the
matter content.
phosphatic
Spherical
fertilizer.
structure formed by a
Green manuring and cover
biotic
crops
activity in
are a
surface
good source
horizon
of organic matter.
and promotes
Integrate
and
infiltration use of organics and
percolation,
fertilizer
aeration, and
for
root
crop
penetration
productions. Some
in
soil
soil.
have a specific
Classes of
structural
soil
problem
structure on
which
the
need
basis
a
of
proper soil
size
management practices for a
aggregates.
better soil um,
Each type of soil
structure.
structure is further subdivided into five classes.
The size of aggregates
Sandy
is
soil. This soil have a problem a low water
certainner
and
of
nutrient
quantitative classifications
retention.
of soil structure,
Retention.
chorus,
The
and sands size
practical
aggregates are
method of
more
improve
favorable
structure of
for
the soil,
plant
such
growth
as
and
soils, is to add organic matter directly or very
through
smaller
a
or
green
very
manure.
large aggregates. So grade of soil
The
structure.
addition of the pond sediments, can clay soil, or even a compaction is helpful in increasing
Grades of a soil
the
structure. It
proportion
is
of
a
small size
qualitative
pores
means of
for
the
the
classification of
enhancing
soil structure.
uh,
Qualitative means
water and nutrient
of
retention capacity.
classification of
Clay
soil
soil. These
structure.
soils have
Grades of soil
restricted
structure are the identified
drainage
on the
and the
basis of the
aeration
stability of the
due to a
grades.
poor
Stability of a grades
aggregations.
refers to a their
Addition of a soil
resistance
matter
to
through helpful for improving aggregation, but the required amount
disruption
is a high.
by
Therefore, a
impact
crop rotation and
of
use
rain
phosphatic
drops under
fertilizers are
a
useful.
submerged condition. It
Raised
is
or raised
influenced
bed
by a moisture
cultivation
content amount and
can
type of
reduce
clay and
the
nature
aeration
of the
stress problem to some
adsorbed
cations and
extent.
organic matter
Um,
content of a soil. High moisture content, colonite clay, developed cations, and high organic matter content make the
Flood
aggregates
condition in
relatively
areas under
soft. Three
prolonged
structure grades have been
waterlogging, the soil aggregations are
identified as
broken,
a weak,
leaching to
moderate,
flooded
and
condition.
strong. Poor drainage and possible solution of a soil problem. Disparate
So,
condition. The problem of dispersion is found in a sodic soil. Grades of soil structure. To describe to soil structure, the sequence, grade, class, and type of the followed. For example, strong, porous, angular,
Maintain
blocky,
soil
moderate,
profile
thin, platy, and weak,
thickness is
fine,
that as a
prismatic
signal
structure.
and slope
Like
increase
a
to
grade, weak. First
the
one is weak,
erosion
so characteristics are
or
poorly
it
formed,
has an effect
indistinct pads
on a climate. It is
which
also a
are
soil
not
forming
stable.
factor. Dredging
Moderately
affects the
developed
runoff
pads which are
relocation
fairly stable and distinct.
percolation
A
and mass
strong, very well developed
movement.
pad which
It
are quite
influences the
stable
aspect which
and distinct.
creates
So genesis of
microclimate
structure.
conditions.
Genesis of
In this
structure refers to
photography
the
also
uh,
seen one
cases
the
and method of
glacially
formation of aggregates.
eroded rock
The following two
outcrop
processes are the
but
involved in
are
the
much
genesis
deeper on
of
the ridge
structure.
beach deposited in the uh, foreground. Time soil develops very slow in Britain.
First
It
one is
takes about
flocculation.
400 years of
Flocculation.
10 mm of soil to develop. Young soils retain many of the characteristics of the parent material. Over time, this uh, uh, queries other features resulting from the addition of organic matter and the active
Flocculation,
of
it
organic.
is an electrokinetic
The soil
phenomena.
of
Electrokinetic
uh,
phenomena
Britain are relatively
is
young
in
because
which
they are
positive and
largely
negative charge are
post-glacial.
involved
An important feature of
in
soils is
soil
that
water
they pass
suspension.
through a
And the
number
clay
of
particles with
stages
a
as they
high
develop,
zeta
resulting
potential
in unique
repel
profile
each
with
other.
many well
With
different
the addition
origins.
of
So this soil profile
flocculating
shows a
agent,
recent
zeta potential
soil
is
in
lowered. The particles come
Flemish forest
closer
which
and
has
attract each other, resulting
formed on
in
the
the
sand
formation of
overlaying on
floccles of s- silt size.
and buried profile.
Floccles are stable as long as the flocculating agent is present. Flocculations also take place
Soil
due
forming factors.
to
Soils are
hydration,
complex and
high soluble
dynamic
salt
systems in which
concentration, and the
many
presence
processes
of the
are
uh,
taking place. Gathering,
divalent or
gathering,
travalent
decomposition,
cations.
and humidification. Soil profile clapillary actions
Cementation
reaching
of
a
locals.
translocation. Uh,
It
Breathing,
refers to
this refers to the
consolidation of
breakdown
a
and
clay
the decomposition
foccolates
of
by a
rocks and
cementing
results by
material
a
so
factors
that
including
they
air,
may
water,
not get
and
displaced.
porous
Once these
pores.
have been
Physical
flocculate,
weathering
as
involves a
flocculates are not a large
continual
than a silt
breakdown or
size,
a rock into a
thereby,
smaller than smaller
therefore,
particles.
flocculations would be
And chemical
unfavorable for a
weathering
plant
involves the
unless these are
alteration of
further
the soil
aggregates
chemical
by
composition
inorganic
of rock
calcium
minerals.
carbonate oxides of
Decomposition and
iron and aluminium and
erosion.
organic
Decomposition
matter
is the
cementing
breakdown of
materials.
plant-derived material
Flocculation
into
of a clay
its
particles is therefore the
simpler organic constitute.
prerequisite for
This is
aggregation. So aggregation is always refers to a flocculation plus where a
accumulated
plus in
by
the cementing agent.
enzymes, earthworms, mites, and other organisms. Unification is the
Factors
breakdown of a
influence the
plant
formation
pigments
and the
leading to the
stability of the soil
formation of
structure. So
different
first
types
one is
of
the physical
humus. It
factors.
is
Physical factors
probably
includes the wetting,
the most important
wetting
biological
and
process
drying,
leading to
and
its
freezing
soil.
and thawing. Alternate
When
wetting and
humus
drying
develops
leads to a
under
formation of a smaller aggregates, particularly
this
in the
woodland
fine texture
where
soil. Drying
this
causes a
plant
shrinkage
pigments
of the
are
soil mass,
actively
and
broken down
when
by
a
a
large dry
pro- prostate soil
cloud
biota.
is wetted,
Further,
rapid
humus is
entry of
intermediate
water
between a
causes
mole and
unequal
mole.
swelling in the
Mole humus usually develops bands
clot, and the clot is fragmented along the
then
cleavage plane. In the
coniferous
process
woodland
of
and
wetting increasing pressure
moorland.
of the interrupt
Different wet
air
climate condition breakdown is
cases
slow due to the absence of soil biota.
distribution of the large
Capillary
cloud into a smaller pieces.
where
Similarly, freezing
evaporation exceeds
cases cracks in the large
precipitation, moisture moves upward,
plot by
raising the
expressions of
soil
a
profile
water.
by a
These cracks
capillary action. It is
cracks
therefore
takes in a
in
more
the
water
reverse
upon
direction
thawing
of
and get
release.
enlarged further of the refreezing. Chemical factor. The
In
chemical
return,
factors includes the
precipitation generally
exchangeable
exceeds
cation
the
and the
precipitation.
binding
As a
materials.
result, capillary action is a
Clay
basic
acts as
rarely
cementing
occurs
agents,
apart from
also
intervallary
swells
conditions.
shrinkage upon the wetting and drying. In certain
Decomposition
also
and
small aggregates are
humidification.
held together by
Decomposition,
a
the
covering
breakdown
of the
of
clay
a
particles.
plant-derived
Exchangeable
material
ions
into
such as the
its
calcium, magnesium, and potassium
simpler organic
have
constituents. This is
fluctuations
the
effect on the clay,
activated
while
by enzymes
sodium
that
has
form
a
and other
dispersing effect.
organisms. The humidification is a breakdown of the plant
The
pigments leading
sodium
to
ions
the formation
dominating
of
on
different types of
exchangeable
humus.
complex
It
of
is
a sodic soil cause
probably
the
the most important
particles
biological
or
process
repel
taking place
each
in
other
the soil. When
and
humus
hinder the formation of
develops
the
under
aggregates.
this
The
is all
Divalent
woodlands
cations
and
such as the
where
calcium and
basically
magnesium
plant
causes the
pigments are
individual
actively
colloidal
breakdown
particles
by
to
the
come together and form
prolific
foccolates.
soil
Calcium also
biota.
help in
Modern humus
binding
region intermediate
the
between mole
organic
and mole. Small
colloids and
humus
clay particles.
usually
Hydrate
develop dense
Swaxe
coniferous
oxide from
woodland
almost
like cedar
completely inversible collide
moorland
upon
under a cool
dehydration
wet
and the
climate condition.
uh,
Breakdown is the slow use due to the absence
and help in
of
forming stable
soil
aggregates
biota.
as in the lateric soil, oxysol, and
It is wherever a rainfall
multi soil
exceeds
called the lateric soil
evaporation
of
and there is
the
a free
humid
downward
tropics. So,
movement of water through the soil
Swaxe
pore system.
oxides also formed a
Soluble
complex with
minerals
humus and calcium carbonate precipitating around soil particles act as the cementing materials for aggregates and imparts a stability to soil aggregates.
are
Soluble
used
salt and
removal from
to
the soil
enhance
profile.
flocculation of the clay even in
Continuous
the
stretching
sodium saturated
lends
clays.
to
Organic
improve
compounds play a key
the
role
upper mineral
in
origins
aggregation
by
and
a removal of the basic cations. Cations
stabilization of
are ions
soil
having
structure.
a
Fat,
positively
fats, lignin,
electrical
protein,
charge. Example
raising, etc.
cation
Also help
calcium.
stabilizing
Lithium is the most
the the soil
in
aggregates, humans
sandy
help in the aggregation by the
soils
forming clay
with
humus complex. Only a calcium
high
humus is a
porosity and is less in
focculating
fine textured
due
soils
its
such as the clay,
tendency of
which
form
have
a complex with organic compounds through
soil with a small soil tilth
the
and some
coordi-
and high porosity leading
the
to free
coordinations linkage the
manganese
magnesium,
and
potassium, and
active
hydrogen and sodium
lithium.
humus is defocculated and does not help in aggregation synthetic soil
Translocation, the
conditions.
movement
Long
of
carbon chain
materials
organic
in
compounds
solution
are also
or
used for
suspensions
soil
from one
aggregation.
horizon
These
to
compounds attach
another is
time wells to the
referred to
exchange
as the
sites of the clay and the
translocation.
bind the clay
Fundamental
particles together.
horizontation,
Addition
the
of these
materials
compounds
in the
in relatively small
alluvial
amounts and
or
can the
pre-horizon
produce a
decrease
good
very
structure even
maximum
a sandy soil.
alluvial takes place east
Biological
horizon near
effects,
the surface of the
biological
protozole
factors.
is a good example of the alluvial horizon. The lower horizon
Biological
beneath
factors, the plants and plant
the
residues
material
help
is
the
the
soil particles to
alluvial
bind
horizon
together.
upon a subsoil B
Um,
horizon between
Gelinations,
the zone
organic
of maximum accumulation.
compounds extrude from a root binds and soil particles together. Root
Soil
hairs
color directly a
penetrate
soil
soil
color is determined by the
clots to create
amount
a
of
point of the
organic
weakness and
matter and state
ultimately break
of
the
the iron.
clot
Soil
into
color is
aggregates. This
also
also helps the
related
soil particles
to a
stick
soil
together
beneath
in
with
a
creamy soil
granular
irrigated
form.
soil with a
Plant
full
residues
magnified
serve
oxygen.
as a food
Having a rich
for
brown color
microbes which
in
play a
contrast,
prime role
the
in the
poorly
aggregates formation and the
drainaging
produce
soil
sticky
often refers to as a gray
substance or decompositions.
under
Microorganisms decompose plant and animals
anaerobic
residues form
conditions
a
and
humus
the
and
pores
this humus binds
humidify
the
water
particles
and
together.
have a gray
Algae,
or a
fungi,
blue-gray color.
actinomycetes, and
Soil with
bacteria which continue the
periodic
living matter
waterlogging
in a soil
are
bind. Soil particles more effectively than the
imperfectly
exchangeable
drained
ions. The small
and
animal like
are often highly mottled
rodents,
with
earthworm, spiders, mites, nematodes, insect,
bioducts of
centipedes, and millipedes,
contrasting
etc.
color.
Uh,
Uh,
facilitated the formation of soil aggregates
Metals
by way of
are often
borrowing,
rusty
turning
in
the
color
soil
and are due
or
to iron
throughoutly
concentration. Such color
mixing
are result
the
of
organic residues
oxidation
with
reduction.
the
Iron
soil.
is the main
Evolution
substance
of a soil
affected by the
structure. The
process. If
soil structure
the
can be evaluated
iron
both of a
is
direct and indirect method.
released
A direct
in
method.
anaerobic environment, then it change
Direct method,
the released
indirect method
heat
soil structure is
given it is the
characterized by the
gray
observing
color
the shape,
of the
size,
waterlogged
and
soil.
arrangement of the soil aggregates. Either microscopically or a microscopically and microscopically in microscopic technique, thin soil section are
The soil
examined
texture
under
is
a
a
various
term
types
used
of
to
microscope
describe
for
as
shape and size of aggregates and
describe and distribution of the different
voids.
size of minerals. Practically in a soil texture range from a clay sand and silt at the extremes to a loam which has all three size reflection present. The main influence of the structure
For
is one
microscopic
permeability, which
evolution, are large
generally
soil clouds in
decrease with a decreasing particle size. Soil fold or right above
clouds.
is
It's
the dense with a poor texture and leads to a poor
excavated
structure.
from the field
It
and
badly
allowed to
due
fall
to a
gently
continuous
gently
section. It
on a
is a
smooth surface which
grayish
breaks
color due
into
to a
pads
low
of a
oxygen
different size
condition. It
and
is a
shape.
poor
Shape
environmental
and
for a
size can
root
also be
development.
observed directly from
Soil
the
fold or
cleavage
left has
of the
been
pads
well
in the soil
managed
profile.
and is relatively
Indirect
loose
method
with
involves a measurement of the size
empire
distribution
codes
of stable
species for a
aggregates,
good healthy root
stability of
development. The
aggregates of the
soil
soil
high is
property.
called silty and clay with a compact
which is the
subsoil
function of
listing
soil
in
structure.
a
Soil is
pore
indirect
spaces.
method, size distribution of
A
stable
portion of a
aggregates.
soil formation, the
So, dry or wet
900% broad
sheaving
which
techniques are
follows is the
used
adopted for the
for determination of
template need
different size stable
availability.
uh,
A question
aggregates.
for a
In
soil
direct
formation use of
dry sheaving
on
techniques,
command is the
the proportion
presentation,
of a stable
and also what factor
aggregates
might contribute
against
to the visible
vibrating
difference
action,
between these
stimulating of
three
the
soils, and
scoring
what type of
effect of
humus is
wind
most
is
likely to
determined
develop
which
in
the
the
provides
environment.
and the index for a
And third one is
characterizing
how do these soil
the
biota such as are formed
susceptibility of soil to
above
wind
acting
erosion.
in
In
the formation of
wet
soil.
sheaving technique,
And
size
fourth one is
distribution of
what
water stable
indicates
aggregates
that the
in
lower part
determined
of this soil is
measurement of the
poorly
stability
infused
of
and
aggregates.
less elevation.
It is evaluated by the degree of the which soil aggregate
What
resist
fifth one is
dispersion.
what
Several
process is
indicates have been developed,
producing the
such as the
layer
stability
in the
index,
soil.
structure coefficient, and dispersion
And sixth,
coefficient.
what is the
Stability
vertical
index
cross
and
section to
is the
a soil called, and what
difference
meaning
between
is
a
given to the
percentage
layer
silt
in a soil cross
and clay
section.
as determined
Seventh
by the
one is
mechanical analysis,
explain
and
the
that
how
the
the relief
often
stone is this
by suspension
photography
of
affect the
soil
soil
sample in
formation.
water. The great
Eighth
the
one is
difference,
why
the
is the
better in the
leaching of a
soil
soil likely to be occurring in
structure.
the part
Structure
of a
coefficient is
northwest
given by
uh, uh,
d minus s upon
northwest
s,
India and Scotland,
where D is a percentage of particles and less than
which layer
0.25
is
mm in diameter as determined by the
this
mechanical
soil
analysis,
is
and the S
elevated,
is the
and which
percentage of the
layer
aggregates is
is
smaller
the
than
soil elevated.
0.025 mm in diameter as
So
determined
here
by the wet
completed
sheaving
some
method.
summarizing
High the
about the
value
soil.
of the structural
Uh,
coefficient, the better is the soil structure. Measurement of the soil properties: bulk density, infiltration rate, hydraulic conductivity, aeration,